Welcome back. So in the last video, we covered a fair bit of ground. And I know we went through a lot, but that's okay. We're going to slowly break it all down over the next few videos. I just wanted to show you what we're working towards. We've got a full end-to-end example here in one cell. And we kind of cut our, well, I did. I'm not sure if you waited for it to fit, but I cut my neural network short. So it only got about a third of the way through its second epoch because it was taking 91 seconds per epoch. And we found out that it was probably taking that long because we're not using GPU acceleration. So what I'm going to do here is just to exemplify the power of a GPU and the beautiful thing about Google Colab offering us the use of one for free. I'm just going to put this here and comment it out just so we know it took 91 seconds for the first epoch. And usually, this is another just little tidbit while it's on the top of my head, is whenever you're running a neural network that's going to load images or load some kind of data, usually the first epoch is about 50% longer, give or take some arbitrary amount. So the first epoch is usually a fairly significantly amount of time longer than the other epochs because it has to load all of the data into memory. But then subsequent epochs, as we'll see in a second, are usually quite faster than the first one. So that's just a heads up for going forward. Now, let's improve the speed of this by going runtime, change runtime type, GPU. I'm going to save. Now, what we're going to have to do, we might have to rerun some cells above because when you change the runtime type, it actually resets all of the save variables that you have. But let's just see if we can run this cell. All we've done is change from not using a GPU to using a GPU. Shift and enter. No such file or directory. Did it delete all of our files? It did. So that's what we're going to have to do. We're going to have to come back up here to get the data. And we're going to have to re-download the data here. We press shift and enter. Lucky we've set up this code cell before. Shouldn't take too long. Do we have it there? We do. Beautiful. And so now we can just go back. We'll go back to our end-to-end example. And we're going to run this cell. Hopefully that's the only cell we need to run. All right, found 1,500 images belonging to two classes. It's the training data. This is the testing data, 500 images. Epoch 1 of 5. What's our time to beat? This is a time trial for the Google Colab GPU-powered instance. We had 91 seconds. Oh my goodness. Look at this. This is just a powerhouse already. How long was that? About 10? 17 seconds. So, wow. We might actually do all 5 epochs in the time it took us to do one, just by giving ourselves a GPU to use. We can even just sit here and talk. This is one of my most favorite activities in the world, actually, is just watching a neural network train. And it's even better when the metrics are coming out pretty good. Like, look at the performance on the training data. Remember, the neural network we're building here is to classify whether an image is of pizza or of steak. So right now it started at 64% accuracy, finished at 85.5% accuracy on the training data set, and finished at close to 90% accuracy on the validation data set. How cool is that? And all of it, what's that? 17 plus 9, 26 plus 9, 35 plus 9, 44 plus 9, 53 seconds. So almost half the time to train 5 epochs as it took to train 1 epoch by just switching to GPUs. So I'm going to put a little note there. This is just for you going forward. Note, if the above cell is taking longer than 10 seconds per epoch, make sure you're using a GPU by going to runtime, change runtime type, and then hardware accelerator GPU. You may have to rerun some cells above. Beautiful. Alrighty, and you see what I mean by the first epoch taking almost double the amount of time as the subsequent epochs? That's just because it was loading data into memory to be able to run and find patterns on. And clearly our network is doing pretty well. And speaking of doing pretty well, I want to let you in on a little secret of what we've just done. So if we search data vision food 101, it should come up. Does it come up with the original? Here we go. This is the original Food 101 paper. Scientific paper. So Food 101, mining discriminative components with random forests. So this paper was published, I believe it was 2014. There may be a date here. You can correct me if I'm wrong. But let's just say it's 2014. They used a random forest algorithm. What we just used was a convolutional neural network. So actually, convolutional neural networks have been around for a few decades now, but they've only sort of recently in the last, say, 10 years or so, become really prevalent and accessible to people like you and me. But what we've done is, where's the results here? So they, on 101 food categories with 101,000 images, had an average accuracy of 50.76%. Wow. Okay, across 101 class food categories. Now, if we go back, and it even says their model outperforms alternative classification methods except for CNN. Oh, what have we done? We've used a CNN. So if we look at this, 50.76% accuracy. This is across 101 food categories though. But with our 10-line convolutional neural network, we've just got 88% accuracy. But again, theirs was on 101 classes, ours was only on 2 classes. But that's just giving you some sort of insight into the power of a convolutional neural network. Now, before we finish this lecture, I said in one of the previous videos that this architecture that we've got here is a CNN model based on the tiny VGG on the CNN Explainer website. So this is going to be your homework for this video. I'm going to write this down here. First of all, we're going to get a model summary. We're going to go model1.summary and have a look at it here. We can inspect it there. There's the input layer, all these different parameters here. Total params, 31,101. But I want you to pay attention to the layers we've built. conv2d, max pool, conv2d, conv2d. Well, this is a bit of a tongue twister. Max pool, flatten, dense. So pay particular attention to this. And now we'll go through the CNN, or actually this is your homework, so you're going to go through the CNN Explainer website. Now this is one of my favorite resources of all time on convolutional neural networks. So I want you to just have a play around with this for at least 10 minutes. Again, there's probably a lot of stuff here that you haven't seen before, but that's okay. Check out the layers of this neural network here and how does that compare to our own. Step through all of these images here and have a read. It might take a little bit longer than 10 minutes, but I'd like you to read through this entire page because this is going to be in the extra curriculum as well. But this is probably the best explanation, or one of the best, because there's many great ones out there, of what happens in a convolutional neural network on the entire internet. So have a play around with that. That's your homework for this video. And the question is, how does this network relate to the one that we've just created? We've kind of given away the answer, but I want you to make the connection yourself. So I'll leave this link here. I'll write down here. This is going to be practice/exercise. Go through the CNN Explainer website for a minimum of 10 minutes and compare our neural network with theirs. Turn that into Markdown. Of course, this will be in the practice/exercise/extracurriculum section as well, but I'd like you to go through that before we push forward with convolutional neural networks. I'll see you in the next video.